Math Blast 12, elapsed time. Write the time shown on each clock. When telling time, it's important to remember that the shorthand helps me determine the hour, while the longhand helps me determine the minutes. Looking at my hour hand, it is on the 2 and has not reached the 3 yet. Therefore, we are in the 2 o'clock hour. So I'm going to write 2 for my hour, and a colon here will separate my hour from my minutes. Now I'm going to look at my longhand and determine the minutes. At the top of the clock, it is o'clock. We're starting a new hour. So the time here is 2 o'clock p.m. The end time, when I look at my hour hand, I have passed the 3, but it is not quite to the 4 yet. So we are still in the 3 o'clock hour. And as for the minutes, I will start at the top. This is the start of the hour, 0, and I can count by 5s. 5, 10, 15, 20, 25, 30. Half an hour, half of the clock is 30 minutes. And we're going to call that p.m. here. So from 2 o'clock p.m. to 3:30 p.m., how much time has passed? Well, I know to go from 2 o'clock to 3 o'clock is 1 hour. And to go from 3 o'clock to 3:30 is 30 minutes. So we have a total of 1 hour and 30 minutes that has passed from start to end. Subtraction. Subtract 77 minus 42. Here I'm going to use the standard algorithm. My place values are lined up for me, so I'm going to take 7 ones and subtract 2 ones, which leaves me with 5 in the ones place. Here in my tens place, I have 7 tens that I'm subtracting 4 tens from, and so I'm left with 3 tens. 35 is the difference, the answer to my subtraction problem. 254 minus 52. For this one, I'm going to use the arrow method. I'm going to start with 254, and I'm going to subtract parts of 52 until I get all 52 taken away here. So I'm going to subtract 50, because 254 minus 50, I know is 204. And then I still have 2 more that I need to take away here. So 204 minus 2 is 202. And that's the difference to my subtraction problem, 254 minus 52. Understanding division. I know when I'm looking at division, I need to know how many total do I have. So for the smiley faces, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 total faces. So 9 divides into blank equal groups. Well, my groups I know are my rows. So I have 1 row, 2 rows, 3 rows. Of how many are in each row or each group? 1, 2, 3. So 9 divides into 3 equal groups of 3 is the same as saying 9 divided by 3 equals 3. For the triangles, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 total items. And we know we could skip count here. There were 5 in each row. 5, 10, 15. 15 divides into, again, 3 equal groups, because my equal groups are my rows here. And there are 5 in each of those rows. So since 15 divides into 3 equal groups of 5, 15 divided by 3 is equal to 5. Word problems. Tommy had 20 red bricks. He arranged the bricks into 5 rows. How many bricks did Tommy put in each row? Well, let's take our total bricks here and put them into 5 rows. Here's 1 row, 2 rows, 3 rows, 4 rows, 5 rows. And I need to keep putting bricks into each of these rows until I have 20 total bricks. There's 15 bricks. 16, 17, 18, 19, and 20 bricks. I took 20 total bricks and divided those into 5 equal groups, and that equals 4 in each group. 20 divided by 5 equals 4. Now I want to make sure I answer the question, how many bricks did Tommy put in each row? Tommy put 4 bricks in each row. Area. Determine the area of the shape. Well, area is the number of square units contained within a flat surface or plane figure, which we know as two-dimensional figures. So with that in mind, I'm looking at the square units contained within the rectangle here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the area is equal to 15 square units. There were 3 rows of 5, and 3 times 5, I know, is 15.